slides. So the first one, it says very simply, what is the relevance of HAM for disaster management, right? So it says emergency, you can see emergency communication, coordination of relief efforts, and also engaging the community, because we go into the community and deal with the community which is affected, right? So that is there. And why HAM is because we seen to be very reliable as compared to even a 4G, 5G network in that situation when the disaster hits. It's a decentralized system. It's not as if a single one breaks and entire thing is gone. So it's a decentralized system and it is resilient. If one handy fails, there's another handy there. So the thing. So eventually, end to end, when you see the performance is excellent. It really has been very effective. Although it might not be the topmost technology, but still it's been found very useful. Now, there are disasters. For us, when we say disaster, we think of flooding, earthquake. So they are all called fast-acting disasters. But there are also slow-acting disasters. One is drought, famine. Then you have coastal erosion. It all happens very slowly, day by day, and one day it's a disaster. So there are two types of disasters, and whether we have a role to play in both of them, because when we say HAM, only the one on the left-hand side comes to our mind. The one on the right-hand side doesn't come to our mind because we believe the government will take care of it. But do we have a role to play there? That's one thing. Now, another interesting thing is, it's not that we play a role in disaster management, but we play a role in preventing a disaster. And I was very thrilled to see this in Mumbai during Ganpati. There is a Aniruddha Academy of Disaster Management. It's amazing. I don't know, sir, whether we can have a structure like this where we pull in together our knowledge. So can we have an extension of that here, where if it is relevant, or we create our own?
And I will let you. I will make a
BTR, sir, if you think that is relevant, then
sure.
Because
I know a couple of them.
yeah, okay. So I was thrilled to see this. So we also play a role in preventing disasters. That is another thing. Now, these are the areas of knowledge on disaster management which I thought is relevant. One is the domain related. When I say domain, I mean the disaster itself. What kind of a disaster? So what are the types? What are the implications? Then roles during disaster. What role we can play? Can we do the monitoring? Of course, we are going to do the communicating role in managing, but can we do a monitoring role, the sensing role, measurement? And also, what are the policies and protocols, where I think we get trained by the Disaster Management Authority, and also capacity building, because it should not happen on a particular day we are called and then we are not able to do it. Right? We must be ready in some sense, to some level we must be ready before we are called to help. So, support by HAMS, what I thought based on my experience is, of course, support the Disaster Management Authority. And we can also support the community. For example, we put up a weather station in near a village. We can be directly in connection with that village and the community. You can also support NGOs like Hitesh and me, our company. We work with a couple of NGOs in that who work, in disaster management, and support Rotary. For example, gets money in matching grant projects. Vijay Chaudhary Saab and we were Rotarians once upon a time, so we know the mechanism how it works. So we can do projects so that we don't have to spend our money too much. Somebody pays for the equipment. Now, amateur radio now comes to ChatGPT. So I told ChatGPT, whenever you want to suddenly make a new presentation, you don't know where to start. So Google ChatGPT, mention any two subjects, maybe related, interrelated, it somehow brings in a relation. So it says that amateur radio guys can do a lot of work, and weather stations are important. You can see what is there. What I was thrilled to see is the word, the term APRS appearing on that. So that is between amateur radio and weather stations. And I said, what about amateur radio and hydrology? This is another subject that interests me. I did a couple of online courses on this. They said, actually these are two separate fields. Yet, whenever even though not directly related, it plays a vital role in disasters such as floods, which is a hydrology phenomenon. So allowing for vital coordination and reporting area. So we know all this, but just to get into the subject. So now comes the weather station. Sorry? No, I'll come to that. So now we come to the weather station. Now we are linking up amateur radio and hydrology. Hydrology is rainfall and climate. Hydrology is rainfall, but climate is attached to it. So this is a typical weather station, right? And this weather station, you will see several things. So now there are some important things. I'm going to spend a couple of minutes on this. First, you see is the rain bucket in between, which measures the rainfall. In a mechanical thing, it just measures the rainfall. It falls into a vessel and then you measure, right? Here, what happens? We have a very interesting mechanism called a tipping bucket. So there is a bucket on a seesaw, a small bucket, which will tip when 0.25 millimeters of rainfall has fallen. So that bucket is at bottom of that. The tipping bucket is at the bottom of this bucket here. So when 0.25 mm falls, it tilts this way. The water flows down. Now another side of the bucket gets filled. So you count the number of tips, and then that tells you how much rainfall has happened. This is how automatic weather stations work. So that is the rain bucket. Now you can you can use an optical photoelectric. This one. This is just from the. It is located on the net right now. I'll show you. I'll show you one after this. This is copy paste on the net. It says these measures. So this is just to explain what it is. So that is one. Now on the left hand side, you see that white thing that houses the temperature sensor and the humidity sensor. These two are critical. Now they are covered by this white thing. It's called a radiation shield. In the olden days of manual thing, they used to have called what is known as a Stevenson screen. It used to be a box within which the manual temperatures and thermometers were kept. Nowadays the design has improved and WMO, World Meteorological Organization, has approved such designs. So we have made one 3D printer for our new model. So it's assembled like this to look like that. This is made of, with a 3D printer, it's made of that material called ASA, which means it's outdoor compatible. So this is required for what? You can have a temperature sensor out in the open, you can have a humidity sensor because that is what it is measuring. However, there is this great danger of radiation. When solar radiation directly falls on the sensor, it will get much hotter than the air temperature. So this is a shield, it's called a radiation shield, by which the air, only the air temperature, the air alone is allowed to pass through and be in touch with the sensor and not the radiation. So this is a very critical design and it's approved by the WMO. The one on the left you see is a anemometer. So it's that cups. So it's like there are other things like a propeller, but this is like a cup, and when the wind flows and then it rotates, and there is a relationship between the wind velocity and the speed of rotation of this. There's a formula available for that. Welcome, please. So that is there. On the right side is a wind vane, and wind vane is just got a potentiometer inside. So depending on which direction it is, you can read the potentiometer, you get what is the direction. Yeah? And then you will see there are two radiation sensors which measure radiations of different kinds. Okay, so that is there. And the whole thing, all the data from the sensors comes to a data acquisition system. It's a microcontroller based board. It can be an Arduino. We use ESP32, isn't it? No. There's one more we use. Okay, ESP32 is used for our console. So there's another microcontroller, and then the pole that you see on the left hand side, it's got sensors to measure the soil temperature and the soil moisture. During what we call as a slow acting disaster, soil moisture also becomes important to know how dry the soil has become. So these are all the sensors that go with a weather station. just to show you an example. Sorry.
Do you have some data that this much soil moisture is there, then this is going to be a disaster, or this is going to be the grade of or intensity of the disaster?
No, that is something which we have to model for a particular region, because that region might have drought, but it might have a dam next by which is full of water. So, based on that measurement, we have to create our own model to understand what is the effect on the society. For example, the soil might be dry, like at this instant, but there could be an irrigation system nearby. So, in general, I agree with you, but we have to do a study and understand how it is to be correlated. Okay, so this is our APRS map. You will see all the APRS of Pune around here, and on the left hand top is the weather station, which is the VU3 India Zulu Kilo weather station. That's the location. So, yeah, just as an example to show you that, and so this is the VU3 India Zulu Kilo weather station on the banks of the Dhokarwadi, just to show you how the things are working. Yeah, the anemometer working, and the wind vane you will see is freaking out. Okay, it's a very light instrument, it freaks out. And so that we have to average it out. And you have to see which is the larger part of the angle that it is doing, because it's so light that even a small turbulent, a small gust will turn it away in a different direction. So that is how it is.
Very picturesque location. You are one of
It's on the Dhokarwadi.
field day can be planned.
Yeah, sure.
How often does it get happen?
It can be, this is in terms of milliseconds. No.
Must have said it. Every 10
No,
seconds.
it is sampled, this is sampled via interrupts basically. The wind speed is sampled via interrupts. This is also, yeah, we process that later, we average it. Okay, let's go. So now, if you click on that, our APRS map, if you click on that, it shows you all the weather parameters that it is measuring. I hope you are able to see whatever from there. Yeah. Now, for slow, yes, sorry.
Data that you showed is live.
Yes, it is live.
Also live and on RF also.
You can see it on the net. You go to aprs.
And is like getting data is one thing, but then processing and interpreting. So for that,
We can work on the algorithm.
We have not reached that portion.
yeah.
Yeah. So we were initially bombarding the APRS every how many times a second?
A minute, very much.
And then Pratik banished us from the site, and then we reformed ourselves and went to update once in 15 days. Now we have been allowed to live there. Now. So now when you're looking at slow acting disasters, you got to have two more measurements. These are all his projects for our company. So on the left you will see this is an evapometer on the salt flats of Gujarat, where seawater comes in and goes. So that measures the rate of evaporation. So that tells you if you have a lake, for example, at what rate are you losing water, or if you have crops nearby, yeah, what is the evaporation rate, and then you convert that using a formula into what is known as evapotranspiration. That tells you how much water you are losing from the leaves of the plants. So they are all documented formula from the FAO, Food Authority, FAO, no, that's the organization. On the right is a system. It's not measuring anything because the pond is dry, but when the pond fills up, it tells you what is the level of water in the pond. It uses a pressure transmitter, right?
Hydrostatic.
Yeah, hydrostatic. Yeah. So these are also required. They are not weather directly, but they can be connected to the same data acquisition system. Now, when we see where all we use in fast acting, we are interested in the rainfall rate. I'll explain. It's not the absolute rainfall. You can have a lot of rainfall happening slowly over many days, and water will simply flow away. But if the rainfall rate is very high, then the land may not be able to cope with it. So flooding can happen. you're bothered about wind speeds. Wind speeds are very important. You're bothered about temperature because sometimes it's the temperature which produces the cumulonimbus clouds and thunderstorms. So you're bothered about humidity because humidity is what feeds into the thunderstorms. And pressure, as they say, the sailor says, when the pressure drops, there is bad weather ahead. So these are all the things you are bothered about in fast acting. Slow acting, you're bothered about temperature, not if too much of temperature, it means life is going to get tough ahead. Radiation, if too much of radiation, so I think it's obvious, evaporation rate, soil moisture, water level, all this you can do. So essentially what are you doing for a fast acting disaster is early warning. But early warning method is just 1 or 2 hours early warning. Suddenly there's a lot of waterfall, there's a lot of rain and waterfall and I'll show you how things can very quickly get out of control. So early warning can be only an hour or 2, not more. Otherwise it should be a forecasting, but that forecasting reliability is another thing. And also rapid updates of absolute values. What is the level now? What is the rainfall now? All that. So those are 2 things which are important for fast acting. Slow acting, things are happening slowly, you're going towards hell. You're moving towards hell, so you can keep continuing to give early warning with trends. But there is time. There is a lot of time when this will happen. As part of our company, we have worked with NGOs which work in a place called Darewadi near Sangamner. In Nagar district, we have provided over 100 weather stations. Not about the number, but the thing is, we understand that how these villages have used these weather stations to adapt to climate change. So now you might think places like Sangamner and all are on the rain shadow region. But towards the west coast, near Bhima Shankar, you go, they have excessive rainfall. But even there you will not believe you have slow acting disasters there. Why? It's very simple. They let the water fall and the water falls down the mountain, and when there is no water, they have to go down and fetch water again. They don't have storage mechanisms near their own village, which these NGOs are addressing now. Okay, now we come to the slide that I showed last time. So the weather station is another tracker system in the APRS network. So it connects to the network via radio. So we have another one called LoRa. Maybe you can later see the advantages, disadvantages of that. So they connect to a digipeater and then it comes to the back end. We discussed it in the last presentation as well. And why are we doing this? Because we want an infrastructure independent network which will work even if there is a failure of the 4G system or mobile radio and any other infrastructure system. So we wanted to do this. Now we come to the subject of the domain. What really happens? A few minutes on this. So we have to understand a concept called a watershed. We have heard this term many times. What is a watershed? Put it simply, it is the land or the terrain on which if rain falls, all the water will collect towards a common point. Right? That is a watershed. So where our weather station is a watershed. I'll show you why is it a watershed. So whenever water falls on this, white is a dividing line. When rain falls on the left hand side, it will collect here. But when the rain falls on this side, it flows away. So this is a watershed. And then you have something called tributaries in between. And normally in a watershed, almost by definition, all water comes out of a common outlet. That's important. So you can have a mini watershed in between as well. This is another picture. Now what happens when there is rainfall? This picture is important. It's called a hydrograph. So when rain falls and you are watching the flow at the outlet of the watershed. So the rain is now falling. There is some 3 mm rain at this hour, then 10 mm rain and 20 mm rain. No, this white rectangular thing is the rainfall, and this is how water flows at the outlet. So you will see that initially the flow is less. As the rain falls, depending on where it falls right on top of the mountain, far away, some watersheds are deep and long. Some watersheds are very, very shallow. So depending on that, you have rain coming, rainfall, and the flow will suddenly go to a peak discharge and it will fall. If the watershed is long and far, this will get delayed, but the peak will come and it will take longer. You can imagine if it's something very close by, it will quickly come and go. So this is important because this peak discharge is what is going to create problems for us in terms of flooding. Now if you go to this, back to our weather station, and if you see, you can see very quickly where the watershed is. See the mountains on the left, yeah,